Hello, today we will talking about the lab is so-called pilot test. We have the name word is the static. That means we will test the pi by using the static load. Firstly, we're talking what is the concept of pi foundation, what is the pi, and how can the pi, this is the load from the superstructure or this is the load from the building. The pi is something like that. The pi is the structure element that penetrates into the ground. And when we penetrate the structure element into the ground, they have some resisting force. The first one is come from here. The red one is so-called friction. The magnitude of friction is dependent on the soil types. For example, if it's the soft clay, they have the really low friction compared to the soil of the steep, such as medium clay or sand. The friction is higher than the soft clay. And also, it's not only the friction. They have the green one is so-called end bearing. For the end bearing of the pi, we have to put the pi chip onto the firm layer, such as in Bangkok, we always try to put the pi chip onto sand layer. In Bangkok, actually, the sand layer is about maybe vary from 30 meters to 60 meters. It depends on the site location. Or in some place, maybe such as in Kuala Lumpur or KL, we just put the pi chip on the firm layer. That in KL we have the rock. We can put the pi chip on the rock and we can transfer the load to the rock layer. Even though, and also we have the other side, such as Dubai, we can put the pi chip on the rock also. And as I mentioned, that the pi resistance composed of two components. The first one is friction, and the other one, QP, is bearing. And friction and bearing, and the other one is the weight of the pi itself. We can calculate the so-called Q allow. Q allowable is the load that the pi can resist the load without any kind of problems. We have to divide the Q ultimate. Ultimate is the distortion with factor of safety. The factor of safety for pi commonly is about 2.5 for design. The pi that resists the load should not have the problem according to the stability. This one is the 1S, and the second one is 2S, is so-called serviceability. Stability is the meaning is that the pi should not have, we have to say, no failure at all. No failure should not occur to the pi. And the serviceability, that means the pi have to service, okay, or we can say that the pi can have to serve. If the pi can service, that means the deformation, you have to check for the deformation of the pi should not exceed than the certain length. For example, if we construct a house on this pi and we have really high deformation, the pi is not failure at all. But if they have the really high deformation, such as about 20 centimeters, maybe they have the crack on the house, or maybe the house cannot use for living. So for the conclusion is that today we will test for the pi. The issue that we have to consider for test, we have to consider about 2S in issue. The first one is stability, and the pi can service or not. The pi load test is that we have to try to apply the load or design load to the pi to check whether the pi have stability enough or not, or serviceability enough or not. The pi load test is something like that. This one is a pi load test that's performed in the onshore or is near the sea. The pi test is something like this. This one is pi test. And after that, we apply the load to the pi, something like that. We can apply the load by using the hydraulic jack, or maybe and we can apply it here, and we have to measure the load acting to the pie, and we have to measure for the deformation. We come back to the case study in Thailand. This one is the pilot test for in the configuration of pilot test in here in Bangkok area. It's composed of this one is first one is a test pie. We have to install the pie before, and after that we have to install a so-called anchor pie. Why we have to install the anchor pie? Because when we test the pie, we apply the load here. When this one move down is here, so the anchor pie will move up. Okay, it's move up, something like that. So we have to install the anchor pie. For commonly for the anchor pie is something like this. We have one test pie, and we have to install 1, 2, 3, and 4 for anchor pies. So that means when we would like to test one pie, we have to construct about 5 pies. So that means it's quite expensive compared to the other tests in the field test. For example, this one is we test for the so-called the Barrett. Barrett is the rectangular pie here. It's really large pie. The dimension of this Barrett is about 1.3 meter to 2 meter. You can see the 1.3 meter to 2 meter. And this one is the test site, actual test site in Bangkok. It's a test site for MRT Pink Line project. You can see that the main beam is really large. And we have the anchor pie around here. And this one is a lot of hydraulic jack because the load is really high. After that, we apply the load to the pie and see what's going on. We come back to the pie is here. The component of this one we have so-called main beam installed around here, and we have the so-called the cross beam. Okay, cross beam, and it's not only this. We have to measure for the deformation. We have to install the dial gauge. This one we have two dial gauges installed here, and the dial gauge have to install in the reference beam. Reference beam is somewhere around here. The reference beam is this one. Reference beam is somewhere around here. Reference beam. The support of reference beam should be maybe the location of this one should be located quite far from the test area to make sure that they will not have some kind of sediment occur on the reference beam. Okay, so this one is the test program. You will conduct this kind of pilot test in the field also, but our pie is really small compared to this one. When you apply the load to the pie, the load is something like this. So this one is this Barrett pie. Barrett pie is size about 1.2 meter to 3 meter. This one is the foundation for monorail. It's a pink line. They have only one pie per one column. That means we have this Barrett pie here, and we have the column. This one is connect to it's only one pie per one column because they use one pie because they would like to reduce the area for the foundation. Because the foundation is the location of the foundation is at the middle, is at the center of the road. So after that, they apply the load to the pie. This one is it's a real one. It's not the I have to say the example. So this pie can resist the load up to about it's very high. It's about 4,500 ton. The trend of the curve is something like this. At this point, you can see at this point, actually the pie at this point the pie is not failure. This pie is not failure at all at this point, but they create really high deformation. It's about 12. It's about 12 centimeter. It's really high. If we use this one to support for the monorail for the train, they have a really high deformation to the track of the rail. The train will be derailed, maybe cause a problem later. So that means it's not only to check that the pie is failure or not, we have to check for the deformation also. Maybe the deformation, it should be around here. And this one, we apply the load and unload, and apply the load and unload for this. Okay, this one is example of the test. We test this one to ensure that the after we design the pie, that can to make sure that the pie can resist the load or not. If it cannot, we have to revise the pie. Or in this side, actually they test, after they test, they can get some parameters from this testing, and they can go to value engineering to reduce the pie length after they decide to save the money or the cost of the project. So for the next part, if you're talking about ASTM standard, how can we test for the ASTM standard? Actually, they have several kinds of methods to test. So in our lab, we follow the ASTM standard for test pie. Before I go to ASTM standard, I will show you that for this kind of test, we install some instruments along the pie. For example, this one, we apply the load about 5,000 tons. The load will transfer to the deeper layer. From 5,000 is about, this pie length is really deep. It's about 60 meters. So the load will transfer at about 30 meters. The load on the pie will reduce up to about 40 and transfer to here. The load will transfer according to the friction that we apply to the pie. If we try to have some free body of this pie, we have the load, and we have this one is the friction. That means the load acting at this section will be reduced according to the length. So you can see that the friction is up to this point, and the end bearing of the pie here is about 1,000 tons. So that means this pie, they have the QS or friction is about 4,000 tons, and they have the QB is about 1,000 tons at this certain load level. So how can we test? According to ASTM D1143, they increase the load in step by step. First, we have to talk to, this one is a percent load. This one is at 100%, we can define is safe load. Safe load at 100%. For example, if we said we have to safe load about 100 tons, we have to test up to this certain level, and we increase the load up to this level. Oh, sorry, up to 200 tons. This one is so-called failure load or final load, and so on. So that means we increase this one as a final testing load about 2 times of the safe load. So that means how much for our factor of safety? Factor of safety is equal to 2. So that means for the pie load test is different than the design of the pie. Design we use the factor of safety about 2.5, but for pie load test we use factor of safety equal to 2. That means we have to increase the load from 100 to 200 and to check of 2S. The first one is 1S is safety. The second one is service. We have to check whether they have the safe and service or not. Safe, the safe or stability. The pie should not fail before this load. So that means you have to increase the load up to this certain level without any kind of failure. How can we increase the load to this? You have to increase the load in steps by steps. The load level, the loading step is about 25%. 50, 75, and this one increased up to here. You have to maintain the load of each step about 1 hour. 1 hour, 1 hour, 1 hour, 1 hour. After you increase to about 200%, you have to maintain the load about 1 day, about 24 hours. And after that, you have to unload from it here and have to wait the other 24 hours. That means if you test for ASTM standard, it takes really long time, maybe almost 3 days for testing. For each loading, if we increase to some certain loading, and if we found that the pi still have the settlement, the rate of settlement is still really high, they have to check this rate. If the rate of settlement at certain level of certain loading level is more than 0.25 millimeter per hour, you have to wait the other 1 hour, but it's not more than 2 hours. That means if I said it talk to quite understand workers, if you found that at each certain load the rate of settlement is still high or the part is not stop movement, you have to wait about 1 hour, but not more than 2 hours. And if you have any kind of pi failures, that means they create really high deformation without load increment. You have to jack the pi until it's about 15% of the pi diameter, and after that you can finish. That means this pi is not passed. Okay, let's make conclusion for this slide. For ASTM D1143, you have to increase the load up to 200% of the safe load. Load increment for each step is about 1 hour. And you have to check the rate of settlement at each loading step. It should not more than 0.25 millimeter per hour. If more than this rate, you have to wait the other hour. It's not more than 2 hours. Okay, if the pi is passed, that means it can increase the load up to this point and come back here. Okay, that means the pi have stability. The other part that we were talking about is how to check the serviceability. The serviceability, actually they have a lot of methods to check for serviceability of pi. But in our lab, in undergrad, we were using check the serviceability according to the law of Thailand. For the law of Thailand, it's here. They have about 1, 2, 3. I will not translate into English. Maybe I just would like to talk about this one by one. The first one is that it said that the total settlement of the pi after you maintain the load about 24 hours should not more than 25 millimeter. So what does it mean? That means when so this one is the one example of the final exam for laboratory. I give this curve and I let you to evaluate that the pi load test is passed or failed. So I increase the load from this point up to this level. So according to this one, you can see that we increase the load up to 70 tons. Okay, 70 tons, that means Q safe is here. Q safe is about 35 tons. And up to this level, I maintain load about 24 hours. They still have some of the settlement. The first issue you have to check the total settlement should not more than should lower than 25 millimeter. You can see it here. This is okay for this pi test. The final settlement is about 16. So that means according to the first regulation or the first criteria, this pi load test is pass. And the second one is that after you maintain the load at 24 hours, the rate of settlement should not more than 0.25 millimeter per ounce. So you can see it here. After you maintain the load, it's from this to that one. This one is about 17, and this one is about how much? It's about 13. So that means the pi movement at this level is about 4 millimeter per 24 hours. Here is the rate of settlement. You have to check whether this rate of settlement is higher than 0.25 millimeter per ounce or not. Okay, if it's lower than this level, okay, the pilot test is passed. This one is number, you have to 2. This one is number 1 and 2. And the last one is that after you unload to have no load acting to the pi and you wait about 24 hours, the permanent deformation should not more than 6 millimeter. So how can you check? This one you increase the load up to the Q max and you unload to this point and you wait around here about 24 hours. How much for the permanent deformation? This one is about 10 millimeter. That means it's more than 6 millimeter. That means it's not passed. Okay, so that means this pilot test has stability and for serviceability is not passed. So that means after this pilot test is not passed, what should you do? If it's not passed, that means you have to retest again. How can you retest again? You have to reduce the safe load. For example, you have to reduce the safe load maybe for this head, maybe up to about here, and you test it again until it's about is here, and after that you unload. Might be around here. So that means the Q, the permanent deformation should not more than 6 millimeter. So if something like that, you reduce the safe load, that means according to the design procedure, you have to revise the foundation. You have increased the number of the pi in your project. You have to increase the size of the pi cap to your project also, that the cost of the project will be increased. So finally today, let me make the conclusion for this lab. Today we will test for our pi in the field according to ASTM standard. But for the time that we test in the field, I will try to make it faster. I will try to reduce. Maybe to consult your TA how much of the pi you have to wait for the pilot test. It should not like that. If like that, you have to stay overnight at the campus. You cannot test for up to about 30 hours. Here you have to consult your TA. We'll try to reduce the time for the test. So for this test is the field test. The one that you have to maybe careful for this test is the safety. You have to keep in your mind that safety first. If there anything going wrong, maybe just run away from the test site. Okay, if it's a sound, if some are failure, maybe you have to run away. You have to try to not to see what's going on all the time you test in the field. Good luck for your testing and safety first.